Okay, so first thing today is we're going to talk about user accounts, and we're going to look at how Linux controls access to files and folders. We're going to look at how we create and manage our users, and then we're going to talk about groups. And the final thing I'll talk about today, which isn't on there, is something called sudo. Sudo, okay? Which is where a user account can become root temporarily to run certain commands. Okay, and it'll all become clear as we go through. Okay, now, the Linux way of accessing files and folders and giving permissions is really, really simple. In fact, it's so simple, it takes you a long time to get your head around it. So it's just like all things Linux, simple ideas, but trying to get the things to do what you want them to do can be quite difficult sometimes. So what we're going to do is look at how we give access to the folders and files on the system. Very, very simple mechanism for doing this. And at the root of it is something called a user. Now, a user can be a person, a physical person logging onto a computer, but also a user can be another service on the computer. So, for example, when you install Apache and get the web server set up, Apache runs under a particular user. There's an Apache user. So if you want Apache to be able to run scripts in your web server, you have to give the Apache user execute permissions on that folder. So Apache is treated like any other user. It's very, very simple. Okay, now, the trick is every single folder and file on your system is owned by a user and by a group. So the first thing you need to think about when you set up files and folders is who should own this folder? Who's the owner of the folder? Who needs permissions on this folder? And basically, it's a very simple command. In fact, Julie and I have done this all the time, trying to sort your permissions out on the Creative. You can change the owner of a file using the chown command, chown, change owner. So you specify the user who needs to have permission, the file that you need to change permissions on, and that's it. And the owner of a file can be given certain permissions on that file. If you've got a whole folder full of files, like I say a web root folder, you can change the entire folder permissions in one go. So if you remember before, you could access each other's files on the system. Remember, on Creative? Well, we've stopped that by changing the ownership permissions on the folders and the group permissions. And the R means recursive, which basically means it will go through all the folders and subfolders and sub-subfolders and change permissions on them all. Okay? Again, if you have a group, you can change the group of a file or a folder. So the key to this is figuring out which owner needs access to this file or folder on the system and which group needs access to this file or folder on the system. And when you create a new account, it creates an account for you, but it also creates a group with your username. So you can give other people access to your files by giving them access to your group. Now, the trick here is we have user privileges on files and folders, and we also have group privileges on files and folders. And the permissions are the same sorts of permissions. So read, write, execute. And the idea is, let's imagine you've got a folder and you want someone else to be able to look at your folder. You simply add them to your group and make sure your group has permissions to view that folder. If you want to be able to execute things in your folder, you have to give your group execute rights and then you add people to that group again. So you can control who has access to your files and your folders, and you can control what they can do there. Now, I've talked about permissions, but I haven't really explained what the permissions are. Okay? Basically, there's three sets of permissions. There's read permissions, which means the personal group can read the files, can see the files and open them up and have a look at them. There's write permissions, which means they can change the files and modify them. And there's execute permissions, which means they can execute scripts and run programs in your folder. That's it. That's Linux permissions. But the difference is there's three sets of people for each file or folder. There's the owner of the file or folder, There's the group that owns that file or folder, and there's everybody else. So, have you used ls before to list the files on Creative? If you put the L flag in, you get a list view, a detailed list view. And if you look at it, you can see there's lots of information provided about each of the files or folders. So let's have a look at this, because this is really fundamental to understanding what's going on. This bit at the end is the permissions. And the first thing you notice is some have a little dash at the start and some have a D. Any idea what the D stands for? It is, thanks Tim, it's a directory. The dash means it's a file, the D means it's a directory, and that's because files and directories, if you actually look at Linux at the low level, they're exactly the same thing. A directory is a file. It just has a special flag on it to say it's a directory. So the whole of Linux is basically a whole series of files, some of which pretend to be directories. That is the owner of the file. That is the group for the file. And as you can see, they're the same, because every user has a group with its name in. So that allows you to assign people to your files. That's the file size in bytes. That's the creation, so the modify date, and that's the file name. It's this bit at the start that we're going to need to explain. That's the permissions. Now, if you go back a slide, can you see there's actually 10 digits. There's 10 characters for every single file. We know that the first digit, the first character, is the directory or file flag. And can you see you've got this RW dash R dash dash R dash dash. Well, look at the bottom one. I put that in to show you the permissions. So you see you've got RWX, RWX, RWX at the bottom there, okay? Well, basically, that bottom example there means everyone has full permission. The owner can read, write and execute, the group can read, write and execute, and everybody else can read, write and execute. So that's the least secure file you can possibly have. And that's sometimes called a 777 or 777 permission, and I'll explain why in a minute. Now, this one, if I looked at this, I'd say, right, the owner can read and write, the group can read, and everyone else can read as well. Can you see where I'm getting that information from? If you look at those digits, those characters. And this is how it works. This is the sort of secret sauce. This is the overall picture. 10 characters. The first flag is the directory flag, which we know about. The next 3 are the owner flags, the owner permissions. The next 3 are the group permissions. And the final 3 is permissions for everybody else. So there's always 3 characters for each of those permissions. And as you saw when we did the list view, you can see what permissions each, the owner, the group, and everybody else has. But also, the reason it's called 777 if you give full permissions is because we like working in numerical values, we assign a binary value to each of those columns. So if you imagine that's a 3-bit binary number, the high bit would be 4, wouldn't it? The middle bit would be 2, and the bottom bit would be 1. So if I had full permissions, it would be 4 plus 2 plus 1. That's where the 7 comes in. So a permission of 7 means you've got read, write, and execute. Again, the group, you've got 4, you've got 2, and you've got 1. So again, the group can have read, write, and execute or any combination. And the same for all the users. So in other words, with a single numerical digit, we can define the permissions for an owner, a group, or the rest of the users. So if I defined a 5 permission, what would 5 mean? Read and execute. That's what the file permission is. Classic Apache, because you want your scripts to be able to read this. You want to be able to read the script, don't you? Apache to read the script and to be able to execute any PHP code that it finds inside it. So if you wanted that to happen, you'd have to set your permissions to 5 to read and execute. Now, when you try to back up your database running a script, anyone try and do that with a PHP script to write a file? I know some of you tried it. I gave you a backup script to back up your database, and you tried to write a file to the directory, and it said permission denied. And that's because you didn't have that magic flag set in your directory. So if you'd had that flag set, you could have used PHP to write to a file. But because we were set to 5, not to 7, you couldn't do that. But now you know this, you can change your permissions and get it to work. So let's look at some examples. Okay, 754 permission, that's classic Apache. Okay, the web root folder that you'll often find, it's got 754 permissions. So let's translate this into what it means. So the 7 becomes binary 111, doesn't it? The 5 becomes 101, and the 4 becomes 100, 100. Yes, you happy with that? So if we then translate that into read, write, and execute, it means the owner, which is the person who put the file in the first place, will have read, write, and execute. That makes sense, doesn't it? Because you created it. The owner, which is generally Apache, will have read and execute permissions. And generally, you give other people read permissions for the HTML and PHP files. So you'll see 754 being used when you set up your Apache server, and that's what it means. So now, when you look at those permissions, you can see what's going on, can't you? You start to picture what's going on. The tricky bit is working out how you're going to use those permissions. So let's give an example. When at the start of this year, everyone could see everyone else's folders, web root folders, remember? And that's because we had to set read and execute so to allow Apache to be able to see your files. Because your files, the owner was you, and the group was you. So the only way we could get Apache to see the files and run them was to give everybody else read and execute permissions. But because Apache could see them, everyone else could see them as well. So we had to protect the files and stop other people from seeing your files and copying your code. So Union and I came up with a solution. Anyone figure out what we did? How we fixed this? We're using users, groups, and permissions. How would you give someone access to your folders and your files? What would you have to do to them? Right, so what did we do? We added the Apache user to everyone's group. Which means Apache could take up the middle permissions, the group permissions, and it excluded other people from reading them, and then we just set that to zeros. We set the final column to zeros on the Apache, on the web roots. So we used groups cleverly by basically assigning the Apache user, so the Apache user is now part of your groups. It can see has your group permissions on your web root folders, files and folders. And that's how we fix the problem. Which means every time we create a new user, we have to make sure we add Apache to that group.
Every user is an individual group?
Every user has their own group, yeah, and we've had to add Apache to every single group. So what we did, being typical Linux, we simply wrote a script, a bash script, to create users. And that bash script creates the user, creates the database user, and adds Apache to the correct user group automatically. And the last session we do, I'm going to show you how to do bash scripting. The basics of bash scripting, how you can chain these commands together into a script and then run the script and pass it parameters. Because that will make your life a lot easier. Okay, so you're happy with permissions. When I say happy, you understand the concepts behind them. It'll take a lot of practice before you get really comfortable with using these. And that's one of the reasons why we want you to build your own servers. Because we want you to get first-hand experience of working with permissions and getting this working. And permissions is part of the assignment. You're going to be creating users and groups with permissions. So let's have a look at the next topic. We're going to look at user accounts. Because your web server your server is very insecure at the moment. You're running everything as root. You're logging in as root, you're running all the commands as root, you're doing everything as root. Root has permissions to change anything. The root account is the super user. Now, with Linux, there's only one root account. Only one person can be root. There can be only one. Okay? Unlike Windows, where you can set up multiple super users on the system. And also, you're told never ever log in as root. Ever, ever, ever. Apart from when you have to. If everything goes completely pear-shaped and all permissions go completely to pot, then you can log in as root. Because root has complete rights on every single file and folder. Read, write, and execute. So if anyone gets your root login, they can cause havoc on your server and lock everything out, including changing its own password. So normally what you do is you'd go in there, you'd create a user account for yourself, you'd change the root password to something completely random, record it, lock it away somewhere safe, just in case you ever need to break into your server, and then never ever look at that bit of paper ever again. You should never ever be logging in as root. The simple way to create a new user is the user add command. Easy. User add, new username, job done. But it's never that easy, is it? Because the problem is, when we set up your accounts, we had to set up extra information to do with the account. The first thing we had to do was we had to set up your Linux shell. And basically there are lots of different shells. Shells are basically interfaces. Now, you know the command line interface you'll be using with Secure Shell? You're using what's called the bash shell. And the bash shell gives you access to certain commands. There's a corn shell, there's lots of other shells you can have. There's about 8 or 9 of them. And each one gives you different commands. So you can change your shell and it gives you different instruction sets and different commands you can use with your account. Bash is the most common one, so we give you bash shell. But just like you can have different user interfaces, if you have a graphical interface, the Linux shells are different sets of commands, different command line interfaces you can use. You know when you had that history, when you put the up arrow and you the autocomplete and some of the commands you were using, they're part of the shell, not part of Linux itself. You change the shell, you use different commands to create users, to navigate folders and so on. And different people use different shells. And what's great about it is you can change your own shell. There's a hidden file in your home folder where you can tell it which shell to use. So you can flick shells and use a completely different shell and different commands if you wish. Also, you have a home folder, don't you? When you log in, you have access to a folder. When you FTP in, you have access to a folder. Well, again, we have to tell it what that folder is going to be and to create the folder. And thirdly, there's something called a comment. And what we do for our comments, we put your full name in the comment section. So we can associate the username, which is the numerical value, with a person. It's just whatever, it's just a string, a little comment. So this is how we add you to the creative server. This is our full command that we use. I've just lifted this from the shell script we use. So let's have a look at this. Now, can you see these little letters with dashes? Those are called flags, and they're like parameters. They like to add parameters to your command. Just like you would you'd have in brackets, wouldn't you, in PHP or... how does Python do parameters? Brackets? No idea. C++ has brackets. Basically what this one does says the flag tells the command you're going to add extra information. So the S flag means shell. And you tell it where the shell is, which shell you're going to be using. So this one, all these shells are in the bin folder, the binary folder. And we're saying use the bash shell with this account. Okay? The D says define the home directory. What's the home directory going to be? What folders are going to be the home for this user? But unless you want to create it yourself, you put the M flag in which says make it. If it doesn't exist, create the folder. And the C is the comment. So what we're saying here is run the user add command, then the S says, right, the next bit of information is going to be the shell. The M doesn't have any extra information. The D, the next bit of information is going to be the path to the home folder. Then the C flag says the next bit of information is going to be the comment. And we simply run that command, and that creates your account for you. So by the end of this block, you'll be able to effectively create your own version of the creative server with everything, all the permissions set, everything working the same way. So in other words, a proper live web server. Database, web, file systems. We're going to do all sorts of things with this. Now, who's had the password reset? Honestly, who's got dealing to reset the password in the last month or so? No one. Okay. What you can do is, if you use that command, the chage, you can force the user to change the password when they log in for the first time. So what we started doing is, because we reset the password, then people just leave it as password, we're setting it up so as soon as they log in, it will prompt them for a new password and force them to change it. And you know how your user accounts on the Windows system, you have to change your password every 3 months or so? Every 90 days? There you are. That's the command to force the user to change the password every 90 days. Okay, there's the flag. There's the flag. So there's the minimum change time. That basically says how soon should they change it. Well, that's 0. That's the maximum. That's 90 days. That's the warning flag. How soon should you warn them to change the password? How many days before it expires? So we're saying here, there's no minimum, so they can change it anytime they want. The maximum is 90 days, and they will be warned after 7 days before the deadline to change the password. And that's the username. So you could write a nice script which automates all this, couldn't you? All these commands, pass the username into it, and automatically generate the accounts, force the user to change the password, set the folders up, set the shell, set the flags to change the password every 90 days, all in one script. And that's exactly what we'll be showing you in the 6th session of this block. How to do all these sort of admin chores. When you do forget your password, that's what we do. You can change your own password by leaving the username off, but we can change your password by using password. Okay? Add a user to a group. Okay? So we can create a new group if we wanted to, quite easily. We can add users to groups. So user mod, A is the add flag, G is the group flag, so we specify the group, and there's the username. So all these bash commands follow the same format. You've got flags and you've got parameters. So once you've used a few of them, you get to understand how these work and the syntax of them. So that's really useful to be able to add users to groups. Another useful thing when you're doing your admin is to know who's a member of your group. So if you were to do this with your creative account, you would see Apache user as a member of your group. And that's how Apache manages to run your scripts. So get ent group, and then you specify the name of the group, and you can find out who's a member of that particular group. What's really good about Linux, it's the most popular server in the world, and there's a reason why it's the most popular server, apart from it being free. It's very secure, but also everything you do is run as commands, which basically means you can create scripts to automate most of the admin jobs that you do, most of the work you do on the server. You can simply paste these commands into a file and then run the file. It'll run the commands. And on the forums, if you get stuck, you can copy and paste what you've tried into the forum, and they can give you help and support on that. It's not like you've got to do screenshots and different tabs, and if you want to, because everything's got configuration files, if you want to migrate to a new server, you can simply download your configuration file and upload it to the new server, and that's job done. The configuration is the same. So working with text files is really powerful. It's much more intuitive. I was chatting to Colin, you know Colin, and he was saying, we're chatting about this, about he's building some servers, and he said it's 10 times faster to work on Linux than it is on Windows, because you can automate so many things. You can just script things. So once he's got one server set up, he can just clone the server by just shoving the commands into a script and just executing the script. And if he also had to create 10 servers, he just puts it in a loop and runs the same script 10 times. So it's really powerful stuff, and you're just getting used to this. Right, remember I said you must never ever log in as root. Ever, ever, ever. On pain of death, yeah? On pain of losing your server. When Julian and I log in to make changes to your account, we have to have root permissions, but neither of us has the root login for the server. We don't use the root login. So there must be some way of doing this. And to do this, we use the sudo command. Now the bad news is for you, on your Raspberry Pi, You'll type in sudo and it will say command not found. Because what have you got to do? You've got to install sudo. So once you've installed sudo, it creates a special group called sudoers. And if you're a member of that group, you can run commands as root. It's very simple. And it puts another level of security on. Because you're never logging in as root, no one can intercept your password, usernames and passwords, your root username and password. Once you're in there, to switch to root, to execute a command, you type in your user password. So the root password never ever gets seen, never gets on the server at all. And you can either switch to sudo to execute a single command, or you can switch to the sudo prompt and then exit when you've finished. So you've got two ways of working with sudo. And that's all you have to do. So if I want to add myself to the sudoers group, I would say add user mties sudo. Only root can add people to the sudo group. So in other words, the last job you ever do as root is going to be to add your user account to the sudo group. But once you are in the sudo group, unless you change permissions, any person in the sudo group can add someone else to the sudo group. Does that make sense? So what we've done on the creative server is we know who wants to be in the sudo group, and we've disabled that functionality now. For example, I couldn't add someone to the sudo group. But the sudo group is the sort of the worst secret of Linux. Let's give an example. You know your Ifconfig command that you use to check your network settings when you set up the Raspberry Pi? If you logged in as a normal user and typed in Ifconfig, it would say command not found. Because in the folder that contains the Ifconfig command, normal users have 0 permissions. They can't read, they can't write, they can't execute, they can't even see the folder. It's not even visible to them. So of course, when you type the command in, it can't find it. So the first thing you do is you say, right, I'm in the sudoers group, so I type in sudo ifconfig. And the first time you do it, you'll get this blurb on the screen. And there you are. With great power comes great responsibility. So you always get that the first time you use sudo, just to remind you that you're effectively becoming a root user. So basically, yeah, you get the lecture. I got the lecture from James when I was made sudo on creative. You get the standard lecture that every sudoer gets the world over. Don't abuse privileges. If someone tries to sudo in who's not a sudo user, it gets logged. There's a log file which contains details of anyone who tries to access sudo. So if you find someone's trying to hack your system and trying to hack it using sudo, you can track it down. You can trace it. It'll give the IP address. It'll give you, all the details about who's trying to use the system. So it's really powerful stuff. And the first thing it does, it says, right, what's your password? So you have to type in your password again. At that point, you are now a root user for that one command. Just the one command. If you try and execute another command, you'll have to sudo again. That makes sense? So it's a one shot. If you very quickly need to execute something as root privileges, you simply sudo it and run it. Now, it can get really annoying having to keep sudoing things. So if you use the S flag on sudo, it actually gives you the root command prompt. So you'll now root until you exit. So basically, your command prompt will change from a sort of tilde thing to a hash symbol, which means you're now root. And you can just run everything as root. You're now root to everything. When you finish using root, you type in exit. It takes you back to your original prompt, and you're now a normal user. So as you can see, giving someone sudo permissions is really, really bad. Are we close? Okay, 1 minute left.
30 seconds.
Okay. 5-minute timeout. Once you're sudoed in, if you execute lots of sudo commands within 5 minutes, you haven't got to keep putting your password in. If you leave it 5 minutes, it'll ask you for your password again. That makes sense. There's a timeout on it.